Hello everyone, Milan from IP Fabric here. I'm a product engineer in IP Fabric, and the focus on today will be visibility and security with IP Fabric. What are we going to do? Let's have a look at a quick introduction, and let's go through the basic as a PowerPoint presentation. Let's go through webinar content and let's see what we're going to do. So the first, we will have a look at our simple topology, which is consisting of a couple of LAN devices, a couple of routers, and we will be focusing on a basic device hardening with our intent rules. I'm going to go into detail into that later on. Then we will take the rules and we apply the rules in the diagram. So we see the flexibility of IP Fabric in a way that we can just simply observe the diagrams and apply our intent rules, which are related to the device hardening rules that we will create. The last part of the webinar will be focused on security and the application path testing over the security environment. We're going to have the switches, routers, and we're going to have a firewall cluster in our system that is supposed to verify the traffic, and we will test the application path through the firewall with the end-to-end path simulation in the IP Fabric. So the first part about a device hardening will be focused first. We will take our devices. There will be 9 devices in total in our network topology. We will create basic intent verification rules to verify that we have correct network time protocol settings and the correct SNMP settings. So we'll focus on NTP sources and the other parameters. For the SNMP, we will verify or see how we can verify the SNMP summary information, the communities that we have configured, and especially the trap host, so we know where do we send the SNMP information. Then, after we create our intent-based rules for the device hardening, we will see how we can create a simple dashboard widget. And with the help of the widget, the rules can be easily applied in diagrams in a way that we will observe directly in diagrams. Okay, is this device compliant with our NTP or SNMP rule, or is there anything wrong? We will have a look at that. And then we have a very quick scenario. We will be implementing a new payment system for the hardware store. So there will be the former payment system, and we will implement a new system with a new VLAN, with a new subnet, and with the application path testing, we will be verifying if the system is working as expected, which means we want to go all the traffic through the firewall and then through transit. We will have a look at that. So for adding the new subnets of our hardware store, it will be 10.241.83/0/24 and with the VLAN 83. So we will have a look in the IP Fabric how we can run the VLAN simulation in the topology, so we can verify if the VLAN is propagating correctly, if the VLAN is having the gateway on the firewall, which we expect, and what is the traffic flow of our VLAN. In the last phase, we will be testing the application security path towards the server, which is supposed to be working as a support for our payment service. So it's going to be 10.241.255.13, which is somewhere in the transit, and we just need to make sure that the traffic is passing our LAN and our routed part of the topology correctly, especially through the firewall. And thank you for watching the presentation, and let's go to the demo and let's go through each points individually. So I quickly close this one. So this is our IP Fabric. As we see, we have 2 baselines. We will be working with the webinar baseline number 2. There are 9 devices discovered, and all are within one site, which will be our exact topology. So I can click on the site and see how the topology looks like. So this is the basic topology we will be working on. I have a prepared view with the exact protocols I want to observe. So basically what I did, I selected just the protocols I want to see. I included the spanning tree. I included the OSPF, so I want to see if all the neighbors are set up correctly over my topology. And here is the transit, which is the other part of the network that I really don't want to worry about right now. And this is what we want to see. So in our topology, there's a routed part consisting of the routers. Then we have two static OSPF neighbors, which we can observe in here. And all the traffic from the switched part of network, including all the hosts, has to go through the firewall. So that's our rule. I consider this the word hosts, which are the server in question. So this host, 10.241.83.13, is going to be our new server for the payment system. This is the old one, and there are two other ones that we really don't worry about right now. First, we will focus on the device hardening itself. So we wanted to go through basic verification or the intent rules for NTP and SNMP. So we can go to Technology, Management, and NTP. There's other way how we can reach the correct table in the IP fabric. We can simply search for that. So I can search for NTP and get the details immediately. There's two ways. So either you can go through the menu or you can just search for anything you really want. It's a very flexible tool. So what we are seeing here, we have 9 devices in total. It seems that we have one NTP source configured. This one is verifying if there's at least 2 NTP sources configured, which is the recommended number of sources. It can be even more. What we can do, let's say, we would like to verify if we have the correct source configured. So we can create a simple NTP rule. NTP source for the lab. And we will say, okay, we want to verify the source. We will include the rule into the widget, which we will be working later on with. I will say correct NTP source, just simple as that. And we say the correct NTP source is equal to this IP address. If there's anything wrong, is there anything else, then it's wrong. So we say the yellow color or the orange color will be as default one. So we save the rule. And we see that everything is compliant, which is fine. Great. And let's move on to the SNMP. So this is the basic SNMP summary that we can see, and we are seeing all the devices in here, and we see the name, location, and the contact. We can quickly check the communities. Okay, here's the IP fabric, here's the read-only, and the prefixes allowed. We can see all the details about the communities in this tab, especially. So we can see or create a verification. Okay, all the devices need to have the IP fabric community with the read-only authorization, and we can verify that as well very easily. These intent rules or verification at the top here are basically only check-in if there's nothing like a private or public community, and just verifying that we have the IP fabric community as a correct configured community. What we wanted to focus on is the trap host, because it's quite often it happens that on the network there are legacy SNMP servers or syslog servers or any other servers that are used for management or monitoring or collecting the traps. What happens is that sometimes when there's some tests being performed on the network, we can temporarily set up a couple of servers to send it to the SNMP to, and we forget to remove those servers in the meantime. So what happens is that we have a lot of legacy trap hosts on our network, and it happens very often. So with this rule that we created before, I'm going to remove this widget, we say, okay, we want to verify that all the devices are using this destination host with this destination port, it has to be v2 because sometimes it's v2, sometimes the version is named v2c. So we just say it has to contain v2. And we want to make sure that all traps are using loopback as a source interface of the traps. That's how it's set up on our Zabbix server. So we want to make sure that we are compliant with that. If there's anything wrong, it's going to be, again, yellow or orange. And we are seeing that there's two not compliant devices. And let's see what the problem is. So this one is especially, it's a wrong destination host. This one, it seems to be correct, but the destination port is correct, version is correct, but there's no source interface. So maybe we can dive into that a little bit and see what's going on the device and see how we can refresh the data. So I'm going to connect to the router 17. And we will check what's our configuration of the SNMP. So eventually we have everything correct, but we forget to set up the source interface as a source for the trap host. So what we're going to do, we're going to change it. So set SNMP trap group and Zabbix. And what we have here is the logical system targets version. Okay, it's going to be different. Trap. So what are we going to do again? We're going to add the source address or the source interface to the trap group Zabbix. So we will include the source interface as our SNMP source for the traps. Set SNMP trap option source address loopback 0. Okay. Okay. So the configuration was updated. So now we're gonna go back to the IP fabric, and what we need to do, we need to kind of re-verify. So we want to refresh the data for a selected host name. So we can do that very easily with IP fabric. We can just go to the discovery snapshot. I will just unlock the snapshot so I can modify the snapshot. I will check this device and I will refresh the data of this device. And we see that IP Fabric can do it very, very quickly. If we check our previous snapshot of 9 devices, it took just 1 minute or 58 seconds to create and to compile all the data. So to collect just one device, it's going to be very, very quickly. Okay, we are collecting data. You can see what's in progress. Verifying the tasks. Okay, the data has been collected and we can go back to the SNMP hosts. And we see there's only one left right now, which we can get rid of later on. So we see how flexible we can collect the data, do the refresh, or whatever else we really want. So we see the R17 has now the correct source IP address configured. So this is an easy way how we can verify the data related to the SNMP and the NTP. And now let's move on and let's see how we can take the data, take the intent verification rules, create a simple widget in the dashboard, and then apply what we created in the diagram. So we will go to the dashboard and the overview. And before I created a little widget over here called management compliance. The dashboard can be edited. We can add or remove the rules that we created. We can add those little radar charts or column charts. So we'll edit this one to see what's included. So what I created is the management compliance widget consisting of these rules. So it's consisting of NTP source lab, SNMP trap hosts, SNMP community name, and other parts for the NTP. The way I added the rule to the widget was, if you remember, with the with the widget that was that I was able to include when I was creating the rule. And because I have this kind of a management compliance widget present on the dashboard, I can easily apply that in the diagrams. So we can go to diagrams, to network. The way we apply the rules is just through these little three dots. And here is the intent verification rule. And we will pick up the widget that we have in the dashboard. So it's the management compliance. And we will see almost all of them are compliant, which they are kind of greenish color. When we click on that, we can get more data. We can see, okay, it's compliant with the NTP, it's compliant with the NTP, with the SNMP, or other rules that we created. This one is orange. We already know why, and it's because the NTP round trip time and everything else seems to be correct. And there was one, I think it was 16, that wasn't compliant with our SNMP trap host rule. And this is the issue. So this is the way how we can visually verify a lot of things that we can create in IP Fabric or that are already created in IP Fabric. There's a lot of things in the intent. You can see if there are any interface errors on the interfaces. You can see if we are compliant based on the operating system and the versioning, or based on the quality of service information. There's a lot of things we can verify even on the end-to-end or in the diagrams directly based on the view that we are currently seeing. So, okay, that is for our intent-based rule. And let's move to our next phase, which is implementing new system or the payment system for our topology. So as we observed before, there are a couple of wire hosts. So there's 83.13, which is the new subnet that we wanted to add. The first one I wanted to focus on is the simulation for the VLAN part. We can easily simulate the VLAN propagation over the network. It's just by a single click. We can add the VLAN 83 that is supposed to be created in topology. And here we can see how the VLAN is going through the network. So we have the server. It's connected to the switch over the interface ET03, the VLAN 83. From the switch, it's going to the other switch over ET01. This one is the root. We can verify that just by clicking, checking the switch port and the VLANs and C83. So we can see that the root ID is equal to the bridge ID, which is the root bridge. And then the VLAN is going to our firewall, which is the expected behavior. And it seems to all be fine. The reason why we have two interfaces is because the redundant Ethernet is consisted of two physical interfaces, because the redundant Ethernet, in the way it works, it's the interface that is a special interface for the cluster, and this is the firewall cluster. So the way it works is either one or the second physical interface currently active. So the like kind of a umbrella interface is the redundant Ethernet interface, and then there are two or more interfaces that are belonging to the interface. So that's why we are seeing two interfaces, but in fact, only one interface is in use, which is gigabit Ethernet 002. If the primary node of the cluster will go down, it will switch off to the interface, but the logical or the umbrella interface written on Ethernet 2.83 will be active all the time. So that's the reason, nothing else. So the first verification we want to run is we want to verify, we're going to leave the scenario, we're going to verify that this little IP address cannot talk to the other payment system that we already implemented before, which is the other subnet 241.255.12. Sorry, it's the 83, 83.13, and the 82.12 is our previous system. So let's verify the end-to-end path between those two systems, which is never supposed to be open. And here's the result. The way we show the end-to-end path over the topology is that we are trying to separate the routed and switched part of the network and the security part. So the routing is going host to gateway directly to the firewall. It's going over the purple or the violet lines, so we can turn off layer 2 to see that. And however, layer 2 is going across the real path, which are the switches. So we see that it's going from the 83, it's going to the switch L1SW4. Once we click on that, we can verify it's going to the other switch. Then it's going to the firewall. And from the firewall, however, because it's in red, we know that forwarding seems to be okay. It's kind of forwarding fine, but there are zone matching rules that are preventing the packets to get through. And this one is just the implicit deny. It's a default policy, which is blocking the traffic, which is what we expect, which is great. So next, we want to verify that our server can communicate with the supporting system, which is in the different subnet and different network. So let's see what it was. So we see that the payment system is 10.241.255.13. So let's verify that right now. And the payment system is going to communicate across HTTP, but we will be switching soon to HTTPS. So let's see how it works. And this is our topology based on the source and destination. So we are going through the switch port, we're going through the firewall. The firewall is not red, which means the traffic is getting through. And then it's going to the transit, which is the part of the network that we don't manage, so we don't care about that. It's fine. We can verify the zone matching rules. So we are seeing it's going from zone CUST 83 to the management. And we see that there is application Junos HTTP, which is permitting the traffic, which is great. Okay, so let's verify if in the future, because we are planning to migrate to HTTPS. So let's see if we can use the secured HTTP. No, it seems that we have an issue because the firewall didn't let us through. So we can have a look what's going on. So let's jump to the firewall very, very quickly and see what's going on. So we're gonna see the config, if it allow me. Let's reconnect. So, okay, I see now. So we have, this is the rule which is permitting or denying the traffic from this zone to the zone where the server resides. We see that we are allowing the source to communicate with the destination host, but the only application that we are permitting is the HTTP. So we are not allowing HTTPS. So we can change that. So let's add HTTPS. Okay. And because the policy name doesn't match the rules anymore, so we can change it as well. Okay. And we're going to rename the policy HTTP to policy, let's call it web. Okay. Let's verify the results, and we are seeing, okay, so we're changing from the application Junos HTTP to HTTP and HTTPS, and we are just renaming the policy. Okay, we can commit that. So we need to wait a while because it needs to commit on both nodes on the cluster, and seems to be good. So let's go back to the topology, and another power of the IP fabric is that we can refresh the end-to-end path directly in the diagrams. So let's refresh the data. We have two options here, or three to be exact. The first option will create a completely new separate minor snapshot from the diagram we are observing right now. The second one will just refresh the data in the snapshot, and that is what we are going to do. So I'm going to refresh that. And again, because of the speed of IP fabric, this is expected to be very, very quick. Okay. So we're seeing that the inventory is filling up again. We're getting new devices, and very, very quickly, we're going to reach the end. So 38 seconds, 39, 40. And it seems that we are done. Okay. We're done. Topology is being calculated right now. It's finished. Great. So let's go back to the end-to-end and simulate again. All right. Seems much better. So the firewall is now permitting traffic. And when we click on it, we can see the forwarding is green and the zone matching rules are now passing the traffic correctly. And we are seeing that the Junos HTTPS is included as well. And the name of the policy is the name we put it in. Okay, that's great. I think we progress with our topology. It seems that our payment system will be operational even on HTTP and HTTPS at the same time. One thing I wanted to verify, because our old system is working as well, but I'm not sure if there was a rule that's supporting that. Let's verify if our old system was using a similar type of the rule, because what we did during the implementation, we just copied the rules from the old payment system and applied it to the new subnet, and it didn't work. So it's kind of strange thing. Oh, and this is interesting because it seems that the old payment system is not going through the firewall. That is a very interesting information to see. So it seems that it was really never going through the firewall, and let's see why, because I'm interested in why is it using the interface GE001.82. I mean, what is this interface? All right, here we go. Okay, so it seems that someone used the subinterface on this router, link it to the host directly before the firewall was even in the topology, and they practically bypassed all security. And of course, it was just a temporary thing. So, okay, thank you for watching the webinar. This was our last point, and feel free to enjoy the recording, which we're going to produce very, very soon, and the article will follow. So have a great day, and hope you will enjoy IP Fabric in the future. Thank you.